So let's move on up, if you like, up the order of things, and we'll start dealing now with hearing. Now, although it's quite small here, this is just really to show you that this is supposed to be the human hearing range in the middle here. And you'll see that large numbers of animals actually can hear above the frequencies in ultrasound areas that we can't hear at all, above, in our case, above 20 kilohertz. And similarly, a number of species, whales and elephants, in fact, can hear in the infrasound region, below 20 hertz. And this, of course, is the area where a lot of natural phenomena, such as earthquakes, storms and so forth, they also resonate in this region. So if you can hear in it, you should be able to detect them far better than we could. To look very briefly at the way the ear works, and I promise you it will be very briefly, you have sound pressure, sound waves if you want to call them that, entering the ear. This is the same for all mammals, and they set up pressure on the eardrum, the tympanic membrane, which vibrates these funny shaped ear bones in the middle ear, so-called malleus, incus, and stapes, hammer, anvil, stirrup, as they're called more generically. They have little muscles in between them as well, which we can actually control. And this sets up a magnification of the vibration, and also it diminishes it to vibrate the oval window at the other side of the ears, and this transmits the vibrations into the cochlea, which has in it a basilar membrane, which has thousands of those hair cells that I showed you, those mechanoreceptor cells on it. And here they are on the basilar membrane, but if you look at the way it's constructed, it starts off nearest the ear, very thick, in fact, and fat, and then it widens out and thins out towards the other side. And the different frequencies resonate at different parts of this membrane. So you've got a beautiful spatial map in the ear of all the different frequencies of sound waves, starting with the highest frequency ones, with the thick fat bit, which you can vibrate with ultrasonics, for example, in other species. So in our case, up to maybe 20 kilohertz. And at the other end, where it's thin and it wobbles, it's better for low vibrations, down to 20 kilohertz. So that's the way that we actually, at the ear and or the other animals, sort out the different frequencies of sound. Interestingly, though, that's the way you hear everything, but you don't hear yourself that way. So when I'm listening to myself here, I know what I sound like, and then I go away and I listen to a recording of myself and I say, that's not me. And the reason that I say it's not me is because what I do is when I speak, I and most other